Welcome to our journey into the fascinating world of the brain's rhythmic dance. Imagine your neural circuits as tiny oscillators firing off in a symphony of intrinsic oscillations that shape how we perceive the world around us. These neural excitability patterns are constantly swirling, influenced by external rhythms like the steady beat of music or the gentle pulse of our heartbeat. Our perceptions, attention, and even moments of awareness are deeply intertwined with oscillatory activity in the brain. Think of the thalamocortical and cortical networks as bustling highways of neuronal oscillators generating theta, alpha, and gamma oscillations, each playing its own tune in the grand orchestra of the mind. Scientists use tools like electromagnetism and photography, fancy name for measuring tiny magnetic fields produced by brain activity, often with sponge scalp electrodes to peek into these continuous oscillatory patterns. By studying oscillations in areas like the occipital regions and parietal lobes, we learn how parietal brain rhythms influence our sensory experiences and spatial awareness. Ever experienced a phosphine flash of light that seems to appear out of nowhere? That's a glimpse into the neurophysiological mechanisms of entrainment, where oscillatory forms can synchronize or phase align to external stimuli, creating a kind of neural resonance. This resonance can be nonlinear, meaning our brains respond in complex ways to pulse frequencies, whether in auditory cortex neurons during music or in motoric entrainment during movement. Our brains are equipped with endogenous oscillations that help with temporal coding, timing our responses precisely. This is crucial in processes like auditory perception, where the rhythmic firing of neurons helps us decode sounds, or in the activation of the paracentral lobe and insula shaping our internal sensations. With advanced multi-resolution models, researchers analyze these ongoing patterns, revealing how neurophysiological processes underpin everything from motor control to motion regulation. For example, the thalamus and pineal gland, possibly influenced by magnetic tissues and magnetoreceptors, even play a role in how we experience microgenesis, these fleeting moments of vivid perception during hypnagogic or hypnopompic states. Sometimes our mind's internal chatter, internal speech, can be influenced by top-down process, giving rise to phenomena like auditory hallucination without suppression. Techniques like exposure combined with response prevention can help manage anxiousness and retrain the retrievability of emotional concepts stored in memory. In therapies like compassion-focused therapy or memory and attachment training, we harness these neural and interpersonal functions to foster well-being. Self-verbalization and cognitive models help us understand and reshape our emotional and cognitive networks. All of these highlights a beautiful truth. Our brains are dynamic, oscillating marvels, constantly resonating with internal and external rhythms. Through understanding these rhythms, we can better tune ourselves to the symphony of life.